Hello students, welcome. Previously, lesson 1, form 4 topic 5, we were dealing with the introduction of the chemistry of metals. So today lesson 2, we want to proceed to the first metal, that is the chemistry of sodium metal. So in this lesson, we'll be dealing with the occurrence of sodium metal and the extraction of sodium metal. Inshallah, in our next class, lesson 3, we'll be dealing with the physical and the chemical properties of sodium metal as well as the uses of the sodium metal. So kindly stay with us until the end of the video. So to start with the occurrence of sodium, we are going to say sodium occur as rock salt, and we said rock salt is solid sodium chloride, which is written NaCl. Then we are having sodium chloride or brine. Remember we said brine is concentrated sodium chloride, so it will be still having the formula of NaCl. Then the other occurrence of sodium will be torona. We said torona is a double salt containing sodium carbonate dot sodium hydrogen carbonate dot 2 moles of water of crystallization. Then next we are having saltpeter. We say saltpeter is sodium nitrate, and it is written NaNO3 as its chemical formula. So we're saying the chief ore from which sodium is extracted is rock salt, and the reason why rock salt is the chief ore is that we're saying this because it is most abundant. That means it's having high percentage content of the mineral sodium and also requires very little purification. So remember we said in our previous class, for an ore to be regarded as a chief ore, it has to have high percentage of the mineral or the metal to be extracted from, or in other words, it must be the most abundant. And we say the second, it has to have less impurities so that it requires less purification. So next we are going to go to the extraction of the sodium metal, and we are saying sodium is extracted by electrolysis of molten sodium chloride. The reason why sodium is extracted by electrolysis method is that sodium is a more reactive metal by process called Downs process using a Downs cell. So let's see how Downs cell look like. And we are saying the Downs cell is surrounded by iron shell lined with fire bricks on the outside, forming heat-resistant wall. So what is the role of heat-resistant wall or the fire bricks? We were told to maintain high temperatures so that the electrolyte does not crystallize. Because once the electrolyte crystallizes, that means the ions will not be mobile, therefore there will be no current that will be passed through the electrolyte. Next, we're saying at the center of the cell, that means at the center of the down cell, we're having carbon anode surrounded by steel cathode. So that means the anode is made up of graphite or carbon, and the cathode is made up of steel. Let's go to points to note. The first one, we're saying the anode is made up of carbon or graphite, and the reason is that because graphite or carbon is inert even at high temperatures, hence cannot react with chlorine gas formed. So the second point to note, we're saying the cathode is made of steel, hence cannot react with sodium formed even at high temperatures. Then lastly, we're saying on points to note, steel cannot be used at the anode because at high temperature it will react with chlorine gas formed. So learners, during the exam you can be asked the reason why the anode is made up of graphite and the cathode is made up of steel, or they can even ask you the reason why steel cannot be used at the anode. So we have stated the reason. The reason why graphite is made at the anode is that graphite is inert, hence it will not react with the product formed at the electrode, that's chlorine gas. The cathode is made up of steel because steel will not react with sodium formed at the cathode at even such high temperatures. The reason why steel cannot be used at the anode is that because steel will react with the product formed at the electrode, that's chlorine. so in that high temperature. So next, let us see how the down cell look like. This is the diagram showing the down cell. So we're having our electrolyte, that is sodium chloride in. So we're having the sodium chloride in, that's the rock salt, that is the solid sodium chloride. So next we're having the carbon anode or the graphite anode, which is surrounding by steel cathode. So this is circular steel cathode. We are having it here. So next again, after the circular steel cathode, we also have something called the hod. The hod is here. It has not been labeled, but this is the hod. Hod. That's the hod. Next, remember we are supposed to have also the steel gauge diaphragm or the steel gauge cylinder. This is the one that we're having. So next we are saying sodium chloride melts at 800 degrees Celsius. Hence, it is expensive to maintain high temperatures due to the high cost of electricity used for heating. Hence, calcium chloride is mixed with molten sodium chloride and fed into the down cell. Remember, sodium chloride is an ionic compound, so it has to be melted, because we are told ionic compounds do not conduct heat and electricity in the solid state. But when they are melted, they will allow electric current to flow through them. That means it will be needed 800 degrees Celsius for solid sodium chloride to be converted into molten sodium chloride. But it is expensive to maintain such high temperatures due to the high cost of electricity used for heating. Then therefore we are saying calcium chloride is mixed with molten sodium chloride and fed into the down cell. So learners, during the exam, if you are asked what are the components of the electrolyte in the down cell, the answer will be sodium chloride and calcium chloride. Those are the two components of the electrolyte, because those two are fed into the down cell. So what is the role of the calcium chloride? We are saying it's an impurity, hence lowers the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius. So what is the significance of lowering the melting point of sodium chloride? We are saying to make the process economical. How? Since it saves on the cost of electricity used for heating. So learners, during the exam, if you are asked the role of calcium chloride, you can just say it's used to lower the melting point of sodium chloride. That's enough. But if you cut the temperature, you have to say from 800 degrees Celsius to 600 degrees Celsius. And the importance of lowering the temperature is to make the process economical by saving the cost of electricity used for heating. And we're saying during electrolysis, sodium metal forms at the cathode, whereas chlorine gas forms at the anode. So next, let us see the reaction that we are going to see at the anode and also at the cathode. So at the anode, we are having chloride ions. We are having 2 moles of chloride ions losing electrons to form chlorine gas. So the observation that we are going to see at the anode is that a green yellow gas is formed at the anode, and that's due to the formation of a chlorine gas. So at the cathode, we're having 2 moles of sodium ion liquid accepting 2 electrons lost from the anode to form molten sodium. So that means you can simplify this equation by just dividing everywhere by 2, so that we are going to get sodium ion, which is in the molten state, gaining 1 electron to become molten sodium, like that. So learners, remember, we have formed chlorine gas at the anode and molten sodium at the cathode. So that means if those two come in contact, they are going to recombine to form sodium chloride. So that means for us to prevent the two to come in contact, we are going to put there a steel gauge diaphragm or a steel gauge cylinder. And we're saying a steel gauge cylinder or diaphragm is suspended between the cathode and the anode. The reason why we are using steel is that we are saying the steel does not melt, as it is melting point is higher than that of the electrolyte. That means sodium chloride and also the molten sodium formed at the cathode. So what is the role of the steel gauge diaphragm or the steel gauge cylinder? We are told it is used to prevent sodium and chlorine from recombining. So next we said we're having an apparatus called hood. What is the role of the hood? We're told it collects chlorine gas and channels it out where it is trapped to prevent it from being released into the atmosphere as it is poisonous gas, hence can pollute the environment. So the role of the hood is it collects chlorine gas and channels it out where it is trapped. That is the role of the hood. Next, we are saying sodium is obtained in the molten or in the liquid state. What is the reason? We are saying sodium has low melting point than the electrolyte. Which electrolyte? Sodium chloride. So next again, it is collected at the top of the down cell, not at the bottom. It is collected at the top. Why are we collecting sodium at the top of the down cell? We are saying because sodium is less denser than the electrolyte. That is the sodium chloride. Hence, it floats on the surface of the electrolyte where it is trapped or where it is tabbed. So next we are saying calcium can also be discharged at the cathode. Why? Because we are having calcium chloride which is added to sodium chloride in the down cell. And we say the role of the calcium chloride was it acts as impurity, hence lowers the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius, making the process economical by saving the electricity used during heating. So that means we are having calcium ion in calcium chloride. So calcium ion will also be discharged, and we are saying the calcium is separated from molten sodium because of two reasons. Number one, we're saying calcium has a higher melting point, so on cooling, calcium crystallizes out, first leaving molten sodium, which is trapped. Then second, we're saying calcium is denser than sodium. That means sodium will be floating on the surface of calcium where it is tabbed off. Then we're saying liquid sodium obtained on the down process is cooled and cast into blocks. The blocks are stored in paraffin oil to prevent it or to prevent sodium from reacting with atmospheric oxygen or water vapor. Remember, sodium is very reactive. That's why we cannot see sodium occurring as a free element. Instead, it always come in combined state like sodium chloride. Lastly, let's go to the advantages of the downs process. The first advantage, we are saying sodium metal obtained has high degree of purity of about 99.5%. Second, the GFO, which is the starting material, is very cheap and readily available. We are talking about the rock salt. Then number three, we are saying chlorine obtained is a useful byproduct because we can use for many reasons. Learners, that's the end of our class today. Thank you for watching.